but I wanted to make it a little girlish since I'm the only female speaker here. So I hope it arises positive sentiments, because, of course, sentiment and sentiment analysis is my today's topic. And so I'm going to give you a very brief introduction to sentiment analysis and how we employ machine learning in this task. Just to give you a little explanation why we even bother with sentiment analysis. Here in this chart, you can see what actually happens on the internet every 60 seconds. So people post 3.3 million of Facebook posts, 44.4 million WhatsApp messages are sent, more than 400,000 Twitter tweets are published. So you see, it's pretty huge text data or generally unstructured data. And of course, we want to mine them. And specifically text data, there are many speakers speaking about or having talks about NLP today. Of course, the reason is that we have this new training data. This is connected to the rise of the so-called Web 2.0, where the content is generated by the users themselves. So, as you see, it's one big mess. It's a very different types of data. It's mostly unstructured. We want to classify it, and we don't want to classify it manually anymore. We want to do that automatically, or as international data corporations state it, companies that can figure out a way how to properly collect, synthesize, and use unstructured data can improve their bottom line, reduce costs, and help organizations respond more quickly to changing market and customer sentiment. So you see that sentiment analysis is actually one of the main topics in today's text analytics, because it saves money. Now, how we do that, or just to make sure we are all on the same page? Well, you probably might know that sentiment analysis generally is the automatic extraction of opinions, feelings, appraisals from the written or even spoken texts. So basically, we want to know what people think. And you probably know that it can be either a binary task, so positive, negative, or actually objective, subjective, or it can be an Oriel scale, so these are the well-known asterisks. Now, as I said, it's binary, so first of all, we want to know whether the message or the statement or whatever piece of text it is either subjective or objective. So in the first example, black ivory coffee is made from elephant dung. You see the objective statement, whereas in the second sentence, black ivory coffee is the best. And it's also, by the way, the most expensive coffee in the world at the moment. And it's a subjective statement. So if you didn't come across black ivory coffee, I would recommend it. I'm not sure if you see that, but the other classification is, of course, positive and negative. So we want to know whether the black ivory coffee is the best or whether it's a crap. In this case, it's actually difficult because it really is a crap, but let's say that it's negative, and you see, that's the context. That's why the machines fail, by the way. And also, well, it doesn't do with the presentation, but I created a proverb saying that when life gives you a crap, make a coffee of it. Anyway, the first thing that would probably come into everybody's mind is just to collect or just to count the positive or negative evaluative expressions in the sentence, right? So here it's pretty easy. You have one positive expression, the best, or a crap, which is negative, and so you say that the overall polarity of the sentence is either positive or negative. If you have more evaluative expressions, you just do the simply majority vote, and that's it. That would be the first thing. How we do that? Well, for this deterministic or so-called deterministic approach, we use the so-called subjectivity lexicons. Subjectivity lexicon is basically the list of all evaluative expressions, I mean domain-independent evaluative expressions. That's also important to point out. And you have many of them. Practically for every language of the world you have a subjectivity lexicon, and there in the lexicon you have all the evaluative expressions. Probably they pair of speech and they put either positive or negative polarity. Simple as it sounds. On the other hand, of course, the majority vote does not work every time, because sometimes the number of positive and negative expressions can be equal. And so now when you have a tie, that's the room for machine learning and automatic classification. So, well, in sentiment analysis, we can use both approaches, either unsupervised learning or supervised learning. And there are several algorithms for unsupervised learning, even though it's not used that often, I must say, at least in the academic research, and as far as I know. There exists Turner's 3 steps algorithm. It uses 0.5 information, and it basically goes for adjectives, adverbs, and the context words. And using the pointwise mutual information, it counts the polarity of this context word. With this algorithm, you can get 74% of accuracy. Not bad. And also, there is a latent Dirichlet allocation where you can use which is also algorithm you can use for unsupervised learning, and again you can achieve from 70 to 80% of accuracy with that. I'm struggling. Negative sentiments. Anyway, the other way would be, of course, supervised learning. And for supervised learning, you can either build a classifier, like the basic probabilistic models, where you get the class labels, or you can use a regression, where you basically get the scale. So for the classifier, you either go for polar or subjective or objective, polar or non-polar, or positive and negative, whereas in regression you get continuous values. Maybe here it's a time to emphasize for both of the algorithms or both ways, you get more or less the same results. So if you go for SVM or naive Bayes or maximum entropy, the results are more or less the same for the same training data. Of course, you need some training data to feed the classifier. You can either use the internet data, so these can be different reviews classified already by the internet users to positive and negative, or you can use the data marked with the referential asterisks. But also for some tasks, and that's what we did, you also need your data annotated, you want to have them annotated manually. And that's what we did, because we really wanted to know whether actually people agree on sentiments, and how can then machines agree on sentiments if people don't. So we decided to use Cohen's kappa, which is good for us because it takes into account the random agreement. So we got Cohen's kappa 0.66, which is for this kind of pretty complicated task quite good kappa, I must say. But of course, we didn't use our linguists and our annotators just for the data annotation, but mostly for some more sophisticated tasks like like rules creating and some other linguistics analysis. So this is my favorite quote by Bedřich Jelínek, or the quote is assigned to him, and he probably once said that every time I fire a linguist, the performance of our system goes up. So this is completely against sentiment analysis. In sentiment analysis, every time you hire a linguist, the performance of your system goes up, and there is an evidence for it, of course. So this is how the classifier looks like. You see that you already need linguistic analysis to perform some preprocessing tasks like lemmatization. Of course, it's advantageous to have your data lemmatized because of the data sparsity. It has an effect on data sparsity. You should have your data disambiguate. Everything we do for sentiment, it's more advantageous to do it on a sentence level. Again, there's an explanation for it, but I'm unfortunately running out of time. So it's a standard unigram back-of-words model with word-based features, and again, this is the linguistic part of it. We can use various filters. These filters are not just linguistics. They can be based on frequency or statistical significance. We can work with selected parts of speech only, because who would use prepositions for sentiments, right? We work with negation, which can be pretty complicated, especially for Czech. When we have a negative concord, you really need to be careful with negation in sentiment. And of course, you can plug in an external lexicon. So we can combine both deterministic and statistical approach. Well, actually, it's not statistical, as you've seen. It's combined statistical and rule-based. So I would call these systems hybrid systems, probably. Anyway, just to show you what we did on Czech, we trained two classifiers, one using lemma presents and a segment as a feature, and the other one did the same, but we also employed some linguistic rules. What the classifiers do, well, they both estimate the predictive power of individual lemmas with respect to positive or negative polarity class, and the training of a classifier is basically building a lexicon of all present lemmas and their predictive power towards positive or negative polarity. Here you can see the results. So you see the best accuracy for the naive bias classifier with the rules is almost 90%. So this is, or the take-home message of this part of my presentation is that even with a relatively small data set, this was some 10,000 reviews from mol.cz, you can get quite good performance. But, of course, not only you want to know whether the statement is positive or negative, but you also want to know towards what entity. So, another part of sentiment analysis is a task called aspect-based sentiment analysis, where we are trying to automatically detect the targets of the sentiment. As for the data, we use data marked on sentiment targets. This is something you probably should do manually anyway. There is a data set we created for that. And as for a pipeline, again, this holds generally. You should apply some preprocessing. Here, probably mostly spell checking, but again, depending on the language, you also apply lemmatization and stuff. Then, if it's the same domain, you can mark the aspects you already know in the data. Then you apply some morphology and, in the best case, also syntactic parsing. And then you apply syntactic rules to find the targets of the evaluation. What we did in this case, because we also wanted to take into account the context of the sentence, was a linear chain conditional random fields, which is a sequence labeling task, as you probably know. So we really cared about the context. And as a features, we either used surface features or morphosyntactic features, or we also employed subjectivity lexicon, and then we added the syntactic rules features. So again, as I said, we took into account the context as well. Here you can see the numbers. What's important is probably this, that we reached the best F-score with the rules for this kind of task. We, as you see, also trained on different types of segments. So these were the data from ALSA, and there was some IT equipment, and we marked it with the targets, 1,000 on positive, 1,000 on negative short segments, and you see that with the result, even though this task is quite complicated, we reached the F-score 65.8. Just for the sake of completeness, now I'm about to end, we also wanted to use some language-independent approaches. We employed neural networks. These should be able to find some linguistic patterns in the data. We tried it on 7 languages, and we used recurrent neural networks. As Jirka already mentioned today, that it would be good to use some recurrent neural networks for sentiment. Ta-da! Here we come. Actually, mostly people use convolutionary neural networks for these tasks, or for text mining tasks, but since we applied syntactic rules and some long-distance dependencies, recurrent neural networks are much better for these kind of tasks. We use some pre-trained embeddings obtained from a Wikipedia dump, and we also wanted to compare it with some logistic regression models so that we know whether it sucks or not. It works as a black box at the moment, or I don't know what's actually really going on in the neural network, because there was part of a competition which is called SemEval, and there were like 40 teams, I guess, from all around the world. They provided us with the data, and we were supposed to do the aspect-based sentiment analysis for it. So we used the neural network, and we won the competition for 2 languages, Russian and Turkish, in the targets from the restaurants domain. But we failed, were average in the rest. So we still want to improve this part of we actually don't know yet what to do with that, but there are some suggestions. We experienced 2 kinds of errors in our systems. This is again general, not just the aspect-based sentiment analysis, but also positive and negative. First, we found some system errors, and then human annotator errors. With the system errors, you can do at least something. You can, for instance, cut off these short segments, because mostly the classifier was wrong when there was some very short piece of a text, like nothing, price, I don't know. And sometimes it got it wrong, or it was incorrect when there was a verb or a word typical for positive review in a negative review, so like quality, price. We don't really, because these words were usually in both positive and negative reviews, so it's a little confusing for the classifier. And then there were some domain-dependent things, like long washing programs is negative when it's a review for a washing machine, right? Concerning the human annotator errors, well, sometimes people were evaluating something they never actually tried. Sometimes they wrote a negative review in the positive part of the website, but it was full of negative expressions because they were complaining on something completely else. So it's really difficult to avoid this. Generally, what is the problem and what you really have to have in mind when applying sentiment analysis is a negation, obviously. As I said, negation switches polarity mostly. Then you have to be careful with adversative coordinations, like sentences with but generally. There are many more of them. Also, some positive, mostly adverbs, work as intensifiers, so pretty, horribly, terribly good. You need to be careful about the context, so that's why you need morphology, right? We struggle with idioms and phrasemes, so anything which is semantically one unit, but the machine, of course, doesn't know that, or it can, but you have to train the anagram model, mainly, I don't know how many gram model, but at least trigrams. And these things are very, very often together, so he's one sandwich short of a picnic, meaning he is mad. You have to have some I don't know, lists of idioms for a given language. Also, named entities. It was already mentioned here today that you should be able to detect named entities in the text. So if you have a village called like this, you really need to be careful with that because, of course, in some contexts, it's not evaluative at all. Generally, what helps us is the formal structure of evaluative sentences or expressions. So people use some emoticons and they repeat the letters and stuff. So this is good for us. That's how we can identify the evaluative structures. On the other hand, we struggle with vulgarisms, especially with the new way how to write the vulgarisms, especially in the discussions, online discussions, when people would be probably deleted when writing down the real vulgarism. They thinking about new strategies, so this is one real example. And of course, pragmatics. I'm coming to the end. So if you find a sentence, go read a book in the book review, then it's probably positive. But if you find it in the movie review, then don't see the movie, go read the book. Pragmatics, right? Also, it's not just a domain thing, it's a cultural thing. Because people in the US, we were working with the movie reviews and we compared it with our results, the results from our colleagues from the US and from Scandinavia. In the US, they write that down, awesome, that was the best movie I ever seen. 2 stars, 2 asterisks. Well, in Sweden, nothing special. 5 stars. Cultural thing. You can't really do anything about it using the machine learning. Sorry, guys, to saying this, but that's life. Yeah. Irony, just trying to avoid the first question I always get every time people keep asking about irony. No, I'm not ironical here, but we are not able to detect irony. Not even people are sometimes able to detect irony. This is the little test, but I'm actually very serious about this slide, so thank you for listening seriously. And special thanks to some of my colleagues sitting here who are also here, so you can approach them and ask them for the details. Thanks.
Thank you very much. And we have time for 3 or 4 questions.
Have you tried using bigrams or trigrams or something like that? Because some time ago I did sentiment analysis too, and this data quite help. Because it's true that they're quite sparse, but on the other hand, they're much more significant.
Yep. We went to bigrams, and it helped in some cases.
And do you work with smileys?
With
smileys?
Oh yeah, smileys as well, I have a long list of smileys, but it's deterministic. It's just a list smileys, which says if you find these three signs following each other, then what? Sometimes it switches the polarity of the sentence, but sometimes it's not, sometimes it's just an irony, so also you have to be really careful. But in some contexts, they can be significant. Plus, there are not just check smileys and general smileys, emoticons, but we have all the Asian stuff, and it's horizontal, it's horizontal and it's totally different. So, but it's deterministic. We only have the list of it.
Two questions that are related to each other. First one is you mentioned you speak grams and trigrams. Do you search also for longer n-grams? And second question is, what are the variables that appear in the regression, or is it just occurrences of n-grams, or do you use some other variables?
Just occurrences of n-grams, so that's for the latter question. And for the first question, yes, well, that was the same question as here, right? So for bigrams, trigrams, that's usually the way how to find idioms. But no, well, as far as I remember, we start with trigrams because then it's pretty costly.
Any other questions?
Sentiments.
Actually, one question. At SESNAM, our research department mostly works on the search engine, and we don't use sentiment analysis. Can you see any reasonable application of sentiment analysis in search engines?
Let's discuss it at the bar.
Okay. Thank you very much.